I'm happy to introduce our next speaker, and it segues very nicely onto the previous topic. And so I'm pleased to introduce Dr. Yara Yingling, Distinguished Professor, Associate Department Head, and Director of Undergraduate Programs in Material Science and Engineering, North Carolina State. And her research focuses on materials informatics, advanced computational models, multi-scale molecular modeling for composite, soft, and biological materials. By the way, you are a soft biological material. And she establishes the Graduate Certificate in Materials Informatics to prepare engineers with data science skills and AI knowledge. And she is now going to bring us into an exercise in helping to guide the development of an AI interface for phosphorus sustainability as part of the STEP Center. And so it's pretty exciting. You're here on the front end of this exciting opportunity, and I think it's going to help Peter out, and maybe it'll help you out in your enterprise as well. So I'm going to turn it over to Yara, who's going to bring us through our adventure in AI this afternoon.
I got lucky because I started as computer scientist and then went into material science and then went all over the place. So it's like ADD, academic ADD, right? So now with AI, I have the best skills because I can do AI and I can do soft materials. And now thanks to steps in Phosphorus. What I'm going to do today, because we discussed like how would we prepare for this, I'll go through a couple of definitions, not to bore you, but to show you what's the state of the art so we can move on what's important. Let me see if it's working. All right, so as a material scientist, I can show you what's happening in my field, right? So this is a number of publications in AI driven for materials. And you can see we are at 1.6 thousand a year approximately of different type of approaches with machine learning, artificial intelligence, data science for materials driven research. Anybody wants to guess what happens in the phosphorus sustainability in terms of number of papers? I did the guess, right? So we're talking about 10, 20 if we separate AI from machine learning, right? So generally speaking, and most of them is still like really medical field, not really sustainability. So it's a little bit different and it's misleading concepts here. And in general, I just show this for comparison. It's a scale graph, right? So you can see the number of publications is not the same as on one scale versus another. So also we see on both graphs, there is like an inflection point, right? There has been a revolution. And the revolution started from 2017. It's called Transformer Revolution. Right? 2017. What's happened in 2017? Google developed a new tool, new algorithm actually, that solves some of the problems from natural language processing. So for example, you can see here, it's an interesting way to see it. I'm also because otherwise I don't see what I'm showing. You can see that we started working with computer vision and other type of systems way before 1998. I got into AI in 2002, for example, formally. And then you can see that we're improving. 0 is where the normal average human, right? So what is normal average human? It's already the human that is tested here to a human that can use computers, read and understand everything, right? So this is a little bit biased kind of opinion there. And you can see that after 2017, right, we have a lot of things that happens there, from language understanding to predictive reasoning. And all of these funny transformers suddenly became not funny, right? So what are these transformers? So transformers are just actually AI models that take all the text, separate it into chunks, and then they basically predict the next world based on the previous. So it's a statistics. It's not smart. It's a statistical approach. There's nothing smart about it, right? So, and then it's used some process to predict what's the new word should be right after several words, right? So it's very simple if you think about it. And then large language models, which is your favorite, ChatGPT, Gemini, Cloudy, Grok, you name it, all of them is the same concept. That's a large language model. So we call it LLM, right? Because the rest of it is bells and whistles. It's just the core. So this is transformers trained on a huge amount of data. All right. So the question is, how much data? So how much data is, for example, 3D model. That's the model that can reside on your laptop. The tiny model. It has read over 1 million books. Anybody else read over 1 million books? Right? And remembers patterns from all of them. Okay, ask me what I read when I was 7 years old. Nah, right? Not gonna happen. The new ChatGPT 5 model, whether you like it or don't, it doesn't matter. It's the cheap one, the mainstream, is 350 billion, right? So compares to 3 billion. So it's adjusted a lot of material. And the paid version is 650 B, right? So this is huge. On top of this, we now have this so-called agentic capabilities, right? So that's basically starting to generate insight from what is ingested and ate up. If we're thinking about, are we still smarter than the average LLM, right? So it's a big question that people get worried about. And so this is again this average human that use computer and being tested. And we can see that the average human has been surpassed in 2019. This is me right here, right? All right, I'm a human expert and I'm already surpassed as well, right? So within certain things. So the next thing is people usually very, very worried about is, well, do they tell you the truth, right? So how these models generate the answer in general. So let's look through this very carefully, because that's one of the important things that we need to understand. So first of all, again, you ask it the question, it takes the question and separates into pieces. Okay, if you ask a scientific question, it's going to understand it's a scientific fact. It's going to look for the information that relates to scientific fact, right? So this is first one. The second one then is going to recognize the pattern of what you just typed in, right? So it's not going to look up in the database. Nothing is looked up in the database, right? So keep this in mind. You cannot look it up. So it's just going to recall patterns that is learned based on the most populous information. So based on the scientific fact, this is what approximately what it should be. So then, of course, does a probability-based prediction after this. So it does statistical modeling to predict the most likely next word based on what the structure of your question. So your structure of the question will bias your answer. Keep this in mind. The way you ask the question, that's what you get. Right? So it's kind of important to think about it. And then, of course, it doesn't know if the answer is true or correct. It's just statistics. It's based on what it's trained on. It's based on the model. Every model you ask the same question, you're going to get a slightly different answer. Right? So now let's go into phosphorus sustainability and ask the question from the traditional LM, what percentage of global phosphorus pollution in fresh water comes from agriculture? Any guesses? What the LM would tell us? Experts? Yeah, it will tell us 80%. Why does it tell us 80%? So this is a free version of LLM, ChatGPT, for example, will tell you because 80% is a commonly repeated ballpark figure. So it uses commonly repeated, most probable, and gives you this answer. That's all, right? What would be the scientific perspective? Well, much more complicated. You're not going to get these complications yet, as of now. But in general, we're approaching that as we're getting better. Of course, that gives us a little bit more understanding of what's the difference between the LLM answer, the statistical, most probable, versus scientific truth, right? Which would be messy, which could be ambiguous, which could be uncertain. And then the expert takes a lot of different data, which calls your intuition or whatever you want. The way they train your neural net right here, right, will give you a best answer. Of course, the next question, when you think about it, it's not bad, 80%, right? So common knowledge. What do you think is the rate of wrong answer here? Let's think about it. What do you think? 100%? 80? 60? 30? Right now? 20? Hold on. 10? 1%? What's the rate of me hallucinating here? Okay, so this is a big question that everybody asking who does not like AI. I'm an AI proponent, so I like it. And because of this, I keep an eye on it all the time, right? So I start my morning by reading the AI news. So hallucination, yeah, you guys all probably heard of it. Okay, saying something that is not true. Like you can see the cow that is now phosphorus plant. Okay? So that would be not a good idea. So what is really the rates of hallucination? Right, so if we're looking at, for example, ChatGPT to release it, the other models don't release it, so I cannot make a fair comparison. Is it better? Okay. So fair comparison, you can see that a lot of people cite these numbers, right? So initially it was 60% and 20% the first kind of couple of editions. And then you can see as time goes by, we're starting to decrease these hallucinations until this model is 1 to 2%, right, of hallucination rate. So it's going to tell you only 1 to 2% in the correct data, versus like 9 to 10% is a broad mixed tasks when you have to have a long answer. All right. So what is my percentage as an expert? Assuming I'm an expert, I'm not an expert in this phosphorus sustainability compared to you guys. But what is my percentage? Give me a ballpark. 20%? 5%. Good job. Generally, humans hallucinate about 30% of the time. Engineers much less, and scientists too. With human expert, this is psychological study, is less than 5% based on fatigue, sickness, all kind of different things, right? So time of day, clarity of the question, all kind of different things. So you can see that LLM now is surpassing the human answer in terms, very specifically, of an expert question. So question that relates to very specific facts, right? You might forget it, it will remember. I can say about 80%, it's gonna give me like 81.6%, right? So it would be more correct. However, still ambiguous task is still us, right? We're still safe with the ambiguous tasks. The next problem, of course, why we think general LLM falls short in, for example, phosphorus sustainability. By the way, in any scientifically driven field, why is it? Generally, it does no science, it does no physics, it does no chemistry. It's all statistics. I just showed you, right? It's all statistics. So it's not related to any continuous equations, laws, or anything information that relates one to another. Another top, we have, of course, fragmented knowledge. So it's fragmented knowledge with hallucinations. If it's not logical, it's useless for us, right? So a lot of things is not for the experts. Data quality issues. The data also is taken from podcasts, blogs, low quality papers. There's plenty of them. So for example, if you ask ChatGPT what is the best exercise routine for you right now, it's going to tell you fasting and weightlifting. Why? Because there's most of the blogs about this. That's all, right? So it's not about scientific evidence whatsoever. So we have to remember that. Of course, poor domain adaptations. So it struggles with technical specificity. Right? Even if you start asking about phosphate forms, the cheap version of ChatGPT, for example, will start messing it up after a while, right? So there's a lot of things. Also, all of these answers are going to be biased if you have a low quality data and a lot of it. All of the answers gonna come from statistics. So if you publish a lot of bad papers, these papers are gonna be taking a priority over the seminal papers, right? So that's very important to know. And of course, cost and inefficiency, training is very expensive. Everybody heard about energy use for LLMs, right? This is terrible. Generally, it's very expensive. And of course, privacy and sharing. Do you think your conversations with chatbots are private? No, they actually give it to you for free. So they train their models on you, right? So this is it. So there's a couple of options when you can take it as non-private. Most of them are private, non-private, right? So you have to pay a lot of money for that. So we found that there's a need to create a domain-specific evidence ground AI, and this is what convergence informatics teams at STEPS got to do for the last 4 years, I think, right? 4 years. So we wanted to have trusted data, lower cost, including low energetic cost, and then transparency and scientific accuracy. So how this can help us in general? So I asked actually our trusted source, which is AI. So all of this is in projected impact on the use of AI tools by 20-30%, projected by AI and sometimes from the reference papers. And if we look at different types of things, we can say, for example, we can have better phosphorus recovery where AI can optimize recovery process and look at new recovery opportunities. We can have phosphorus mapping and management, right? Use predictive mapping that we just saw that and look at the monitoring different soil nutrients, plan applications. We also can actually do it more holistically, right? So we can layer many different type of data, connected, integrated, and have a very holistic approach for that. Water treatment efficiency, right? So you can see that increased nutrient removal efficiency, reduce high intensity processes, also prevent certain unexpected processes that occur, right? Give you an on-the-fly warning what's happening there. And precision agriculture optimization, of course, if you have all this information, you can be precise for a specific farmer. Say your soil has this, you have this, and this is what you should do, right? So that's what the AI can promise us in general. So it's a huge increase. It's amazing how many different things we can do here in order to help the planet, help the farmers, food chain, and everything else. Let's look at now what we did in order to start this process, because again, we were concerned about security of data. We don't want to share the data with AI tools, especially since at some point they will not be free, right? We did not want to spend a lot of energy. We wanted to have very high knowledge of the papers. We wanted to make sure that only seminal papers are included, not just the statistics. So you've seen it probably before from step slides, right? So we have the very fragmented data landscape and very huge data landscape. We have many different type of disciplines working together, many type of different types of data, sources of data, different language that we use as we started in steps. Initially, just trying to understand each other definitions, right? There's a lot of different things like that that makes this type of research very difficult. Again, traditional databases that we try to find data from the database, it's not that easy to find data in traditional databases. They're all fragmented, separated, and all have different formats. So even if you have the data, you're not necessarily going to be able to use it whatsoever. It's expert only can use it. So it's hard to integrate. So our ultimate vision was all of these things can be actually taken by AI. AI can understand human language. It can make semantic combinations with different disciplines without us going and being expert at every discipline, sub-discipline there. It's also can have this convergence informatics platform that will integrate all of the data and then figure out hidden links, correlations, non-obvious observations, help bridge scales, and of course, democratize the insights. Because your AI tool can talk to you the way you are ready to receive, right? It can talk to you like an expert, or it can talk to you like a consumer. You can specify it without rewriting everything. In convergence informatics specifically, we are so a little bit more technical, pardon for that. We take all of this data and then we have generate. So this is your LLM, your ChatGPT, whatever it is. We don't use commercial products, but that's the same concept. It takes all the data and then it allows you to do different types of optimization. On top of this, we had to develop a lot of different tools for phosphorus research. So for example, we needed to fuse different types of predictions and experiments. So we developed tools that allows us to fuse some of the data. Data fusion is not easy because two different types of observations can give you different uncertainties. So you have to merge it together. We figure out the workflows that allows us to expand on the small data. Very often we have a very small data and then AI doesn't like it. Because if you have only 5 points, AI is not going to help you, right? So we figured out how to work with the small data. We figured out how to use sparse data. Like for example, groundwater was very, very sparse data. We worked on AI tools to fill the data gaps and complete the maps. We worked on different uncertainty quantifications for each of the fusion steps to understand statistically what is our limitation, what is the lowest information source. So basically trying to create a very high quality framework. And then we applied it to different types of specific examples. You can see that chemical synthesis optimizations, finding some different types of materials, and for example, groundwater testing. So since this paper is already out of Paul Westerhoff, I'm going to show you a couple of things, right? So this is, we took 140 years of sparse groundwater tests. So for example, for North Carolina, sorry, field data looks like this, right? So this is all of the testing locations that you have. And it's not necessarily fun to try to predict something on a scale of North Carolina that looks like that, right? So that's not going to be useful for you to predict where's the next hotspot occurs and what's going on here. We use a couple of things. Was imputation. So it's a machine learning imputation, allows you to use chemical co-occurrence, statistical co-occurrence, and a little bit of rules of chemistry that allows you to fill the gaps For example, iron and phosphorus are interrelated, right? So you then, if you measured iron and other things, you can actually, not just binary, but it's much more difficult ones. This allows you to start filling other testing relocations. So if the data point was tested for anything, we were able to impute it and give a full composition of all of the chemicals there, if it was tested. If it's not tested, nothing we can do, right? So if it's not tested, I mean, okay, I can make a prediction based on all kind of other type of sources, but not the groundwater testing. So that allows us to predict the size of the future hotspots because we had a timeline and XYZ and all of the data, right? So because of this, we can say, all right, in the future, we're gonna have the hotspots of the phosphorus, and that's what it's gonna look like, right? So again, hiding all the technical details. If you have questions, I can answer it later. This is an example. So now, like, we have all of this, impute complete data set. It gives you full scale risk assessment, right, without cost delay. It's actually because you test and you train and test, right? So it was actually pretty careful, as careful if you can do an experiment, taking it to the lab, almost the same probability. And then we have more accurate risk predictions, better resource allocations, and just generally smarter decision where we can go next. All right, so now I'll go show you the tool that we developed because we're about ready to release it. And this tool we call PASTOR, Phosphorus AI for scraping, tracking, optimization, and research, right? So this is our PASTOR. The cool thing about PASTOR is a lot of bells and whistles. Again, spent 4 years in the development that you start with the user data. So you have some data or you have a question. It doesn't have to have a data. You have just a question, you need to have some observation. So then we have another source of information, which is databases, papers, all kind of different type of things. So using concept of so-called knowledge graphs. So this is again semantic learning. It can mix everything together with natural language processing and then put in the same observation in the same nodes. It connects all the data. It doesn't matter what you put there. You can put policy, you can put agriculture, you can put wastewater. All of it's going to be together. And then we allowing it with a couple of tools that we had to develop exchange the information. Notice that this exchange here is possible, but not necessary. If you don't want to share it, you don't have to share it. We start thinking about security, but because you have these two knowledge graphs are aware of each other, within the information, you're going to see instant comparison of your data or your question to the literature, right? So this is traditional LLM, a little bit more fancy, but the concept is very similar. So from that point on, we also added personalization, personalized chatbot that allows you to interact with this data the way your training allows you to. So for example, STEM background, phosphorus expert, non-expert, I'm K-12, anything, policy, agriculture. So you put what you are during the registration. What is our really bells and whistles here? One is we have human curated data. So we make our steps participants work on it to determine seminal papers. We also had a postdoc who went through all of this data very carefully, made sure there's nothing there that is not supposed to be there. So all of this is trained in absolutely precise data that is accepted by the community. And another one is that we have all of this on the local machine. So it's not using any calls to commercial partners. It has a free source, tiny LLM, 3B, the one that I showed you, with 1 million books. So basically, it has a language capability plus enormous understanding of phosphorus field in general, right? So that's what becomes sustainable. It can sit on your laptop at some point. Right now, not yet, but soon. On a gaming laptop, it's already can sit, right? You can disconnect from the internet and still interact with this tool. Let me go a couple of things. Human curated data, why is it important? Right, so it's again trusted evidence-based research. So for example, when we just an example, when we started from the search of the publication, phosphorus and sustainability, we saw 7,000 publications showed up. After curation, we only had left 3,300. And the other ones were not considered to be a quality. Then data, once we have this curated, the data is going to be extracted, classified, and labeled. And see, extracted and classified. Classification is the most important one. We separate in the subcategories. So when you are searching something, you're gonna come, if you are in a subcategory, it knows how to personalize it for you based on your registration. AI personalization, why is it important? Many different types of studies already show that personalization improves the learning, understanding of data, all kind of different important things. Why did we do that, right? So just in general, because it seems to be like an easy to do. If I ask the same question, which option is best for capturing phosphorus for wastewater, it's going to give me 3 different answers based on your profile, how you registered. So for example, if you're just a consumer, it's going to give you a pretty simple thing. The best options to turn wastewater to something useful. Okay, and some little things after that. If you look at the policymaker, you can see that's now starting much more detail, but in a different type of language. It's using a different type of approach. And a few researchers, okay, it starts very uncertain, right? Effectiveness depends on composition and scale, because researchers like that, more information. So that's we also can do like K-12 and all kind of different things and start to talk to you in a different formats. That's democratizing the knowledge and allowing us to do things a little better. Another thing we did, we added powered podcast generally because it's easier, accessible. You also can listen to this as you're walking or doing something else. You can combine many different papers. It makes complex science. It starts with explaining what the paper was about from the general LLM, and then it goes into more details about this paper. And complements text and visuals, wider reach, personalization again, and efficiency. I don't know if I play it, and it's gonna, I know that, oops, no, I can't. Maybe it's not gonna play. Well, I cannot play it, but it sounds really good. Probably because we, right. So if you click on it, it gives you a very good overview, for example, of the research paper. It starts like an NPR podcast, right? So what is this about in general, and then dives into the paper and details. Very comfortable. Yeah, it does not play. Okay. So let's see if I can reach my tool, because this is our tool. And I'm hoping for this, but we'll see how this is gonna happen. All right, so you can see that this is the tool that allows you to do a lot of things. Let's look at what it does, right? So here's just the tutorials that allows you to understand what's happening step by steps. If I go to public data, I'm gonna see papers. So public pastor is our AI chatbot. It's gonna interact with this data. And then databases that is also public databases. So if I click on the papers, then you have to complete the registration, and it's personal because once you complete the registration, it knows me that I'm enthusiast about phosphorus sustainability and an expert in STEM, right? For example, that's what it knows. So it talks to me the way it should be. So right now it's loading the papers, and it's gonna show you different types of information here. Oh my gosh, it's gonna be hard to type it. So for example, if I go here and I type in something, I don't know if I did it correctly. I'll wait for it. It should show me preview. Maybe my laptop would show it. This is not. Okay, let's go to the pastor. All right, it's better. Okay, I'm gonna ask you the same question. Is it? As we asked before, what's the percentage of phosphorus runoff? I'm not seeing what I'm typing. Okay, so you can see it's answering right away. So I will show you the papers later as it's loading. Notice what it's showing you here, right? So it shows you relevant score. So this relevant score based on the answer is going to give you so you notice that give you direct links to information in the relevant score. Relevant score is the composite score that has, if the paper was labeled seminal, right? So it's outweighted. If there was other citations to other papers which either supported this claim or contradicted based on the language, right? When we do natural language processing, it's my paper supports that. It goes as supporting, contradicting, mentioning. Mentioning, you just, somewhere in introduction said this is also related, right? So that gives you a score and then a weighted score. is balanced on the seminal papers are more important. So it's going to outweigh your answer here and give you a more precise. You notice that this is more what scientists would be expecting from the first slide, right? So it's not 80% right off the bat. So it was much more detailed, right? So if I click on any of these papers, I will be able to see all of the related papers here, right? That is related to in this interactive knowledge graph. You can zoom in, click on it, whatever you want to do it. I'm not going to do it because it's not easy without a mouse as well. You can see it tells you it's open access, and then it separates here topic centers, methods, and so you can see it. And here it gives you an automatic podcast as well if you don't want to listen to it, or if you prefer to listen rather than reading. We're all trying to save our eyes at this point, right? With any information. So it gives you all this information. Notice it's not a seminal paper, so it's not labeled as such. On top of this, as a community, you can give comments to this, right? So if you like it, don't like it, you can also comment it out. Okay, a couple other things that is important. If I go to, for example, databases, you're gonna see, well, steps participants gave us the databases. So it gives you all kind of different type of databases. You can see other databases versus steps. Steps is from publications. Other ones are all kind of different related databases. If there's as a free and you can see it, it's gonna show you what's the metadata looks like. If it's not, you will have to work on it a little bit more. It's a question if I, so you can see that there is Explorer, shows you different stats bars, right? So for example, Yingling data has 3 out of 7 data sets with sample data. This means you right away can preview the data. It's much better than most of the databases I've seen in phosphorus sustainability. I click on it, there's no data, I click and click and click, and I'm going through a lot of clicking until I finally may or may not find the data, right? So there's a lot of things. So this is right away tells you this is with the data, this is maybe requires more clicking or something else, right? So that's the convenience for researchers. Okay, let's go up. On top of this, we can work with your proprietary data. So this is your proprietary data. You only work with your own. So for example, if I go to create your own chatbot that's going to talk to your data, so it's completely secure. You can have a workspace where you can, for example, download all kind of data here. So you can see this is one of the data files that we were testing. So it has a lot of different data. So it's an example. I cannot see what it is, but it's one of the examples. It's right away shows you a correlation. So all of your tabs here are correlated, right? So if you have a very high correlation, it tells you it's highly correlated data. You can start doing machine learning. If it's not, it's not. So for example, if I go down, and pick up something that is not like this one. Okay, so this is a correlation here. What else I can do there? There's a lot of different tools here just for plotting and understanding your data, right? So then, and it's also a little bit of machine learning. We'll add more tools in it. So this is linear regression. For the nominal regression, you can look at all the different fits that instantly lets you understand it. And there's explainer piece that comes and explains to you what you just seen and how it relates to your process. Again, natural language processing allows you to go through it. If you want to interact with you can put your own papers here, upload to scrape more. There's automatic scraper that allows you to do that. Or you can create your own chatbots. So here's different type of chatbots that allows you to interact with the data that you uploaded it. So for example, I have some kind of data that I already put there. I can start talking here. It tells it it's just mine, right? So there's no interaction with even my LLM at this point. It's just talking to this paper. And I can ask questions about this paper here. So that's what we try to develop. So this allows you to interact with your data. Again, there's a lot of bells and whistles. There's highly curated data. This allows you to separate things and work with it. All right. So this is a general company. So how did we check the trusted answers, right? We checked it against all of the big, powerful chatbots, and we come about 10% better in terms of answers. So if it's confidence 86% in expert answers for the phosphorus sustainability, we come almost 95%, right? So it's pretty good actually in terms of answering questions. Also allows you to do your data and your papers. The future will add a lot of machine learning tools directly. So it's going to do machine learning on the fly, not neural nets, because neural nets requires expert. Everything else, clustering, regression, what is it, rare events predictions, whatever you need, right? Depends on the classifications will be there. We will also do multimodal interactions to richer outputs. Example, of course, if you, for example, use future faster capabilities in wastewater treatment, you have a problem, delayed detection of water quality issues. It will give you on-the-fly AI anomaly detection. If you have inefficient phosphorus nutrient recovery, you can analyze and optimize chemical usage and recovery. The same goes for agriculture. And of course, if you have difficulty in handling peak loads and variable wastewater compositions, also can have predictions and about fluctuations and allowing you on the fly correct your output. What else we can do? So we can do a lot of different promos, right? Bells and whistles. We'll see if I can come out again. It's going to be better. Right. So for example, we can create children's books. So that would be about the phosphorus. And we can listen to this, right? And it's going to tell you about Pastor specifically in less than 2 minutes, and how we step CI team is super brilliant scientist. Of course, we have to say it, right? We didn't say it. AI told us about us, right? So it's been better. So, for example, this was created about this forum just for fun in less than 2 minutes, right? I didn't give anything except this is the forum and the website to the conference website. Whether you like it or not, it talks about us talking about, for some reason, agriculture specifically, not my fault, probably on the website. And you can see this gives you all of the information from the stock videos. So you can see that that's a free, all of this content is less than 2 minutes. So that's kind of the bells and whistles in the summary. We do have a lot of things. I can give you a 3-hour lecture on this because I have a lot of things that we do with AI, right? It gives you a lot of different things if you have an ability to understand what you need, right? So again, my group and my team, we are very much interested in making AI work for us, not us work for AI. This is one of the philosophy. And because of this, we're trying to develop that type of future. This is a nightmare future for everybody. We are here, right? So we're collaborating with AI. Who knows what's going to happen next? You know, if we don't develop the better AI tools, we're definitely going to be in the position where there's none of us there, right? So I like to thank STEPS and NSF for funding and my whole team, STEPS Conversion Informatics teams that participate in some aspects of this research. Thank you. I'll take questions.
Okay, we have time for a couple of questions before a break, and then we can all mob Yara with our questions and ideas during coffee. Yes, sir, back there.
Seems like a really cool approach. Thank you very much. Is it possible to link that with some other input other than text, like for example, Google Lens, where you could have identification of individual plants to help farmers or weed control or other inputs graphically or visually other than text?
Yes, we already put images there to train it on the images as well. So it has a full computer vision capabilities as well. So generally, I refer it to text and data as the easiest thing. Data for me is image as well, because pixels are data, right? It's just a different format of representation of the data. So it is capable of putting, by the way, this tool generally can be lifted off from phosphorus sustainability and retrained in any type of other discipline, because all we do is retrain we need the seminal knowledge that you want to use, and then that's it. And then we're trying to make it even more sustainable to move it into the laptops instead of GPU. Right now it sits on like $5,000 workstation, right? But this can be smaller.
Thank you so much. This was great and fascinating. Please allow me some questions. By the way, my name is Gerald Steiner. When you say seminal, work in papers. I mean, actually, how you define that? I mean, actually, it's like the citations alone don't tell the full story, even like the journals. So Nature, as such, is not necessarily always telling the truth. And that brings me actually also to communities. It might be that a community or disciplines are kind of misleading for some time before you make an evolutionary change at the knowledge basis. And that brings me to the third issue, which is the role of a group. I mean, when you say the system learns from you, are you using like the individual profiles, or would it also be that, say, for example, that the system identifies groups that might be related to a discipline, to an institution, or even to a thought of school, and then like make its own learnings out of it?
So let me start from the last one. So the system learns, so this is the ChatGPT Gemini, they learn from you interacting. Our system, we're not allowing it to relearn from you, except that if you comment on the papers or the seminal sources, whether you can comment, this will be taken into consideration based on your profile. Right, so if I'm K-12 and I don't like the database, it's not going to take it into account. But if I'm an expert in Phosphorus and I say this database is faulty, it will take very serious consideration of that. So we're putting algorithmic approaches on top of GenAI to really try to bring this knowledge. Okay, so let's talk about that seminal, right? What seminal for us means. So luckily for Phosphorus sustainability, we have this huge community that gave us what they consider is state-of-the-art seminal papers. So that's what we labeled as seminal. If I go back to my field, for example, we have certain books that experts know this is an excellent book. They're not old, everything there is correct. So that would be the seminal book, right? So that source would be outweighing some other things. Not that you're not going to see it. You're going to see it. This is high confidence. This is other thoughts that can be there. So it lets you be human in the loop. You get this information. You can decide, okay, I like it. And then you can correct it by making a comment. So it doesn't look at your data of what you're putting there and how you interact. It looks at your comments. So when only if you want to tell AI it's not correct about something, it will take into an account. Again, based on your entire history too. So you will be prioritized based on the expertise level. Did I answer your question correctly? Okay.
Okay, thank you, Yara. It's fascinating. I don't see how you trained on 3,000 seminal paper because I've only written a couple hundred. In any case, so thank you, Yara. That was incredible. And I know that everyone wants to talk to you about their application or their input on that system. So thank you so much. Thank you also, Peter, for your outstanding presentation. And now we have a coffee break before we break into a separate session. So we'll see you after the break.